In this video, we will be deriving the expected value of the random variable x, which follows the exponential distribution. For this random variable, we have this probability density function, which ranges from 0 to positive infinity. So the first thing we're going to do is to apply the definition of the expected value. We're just going to integrate from 0 to infinity x multiplied by the probability density function. And in our case, the probability density function is just equal to lambda multiplied by e to the power of negative lambda x. So for the sake of simplicity, let's just pull this lambda constant outside of the integral to keep things simple. So the only thing we have to do now is to evaluate this integral, and then we can do this by using integration by parts. We're going to consider this term over here, and then we're going to split it into two separate components, the x term and the e term. So the first thing we're going to do is we're going to find the antiderivative of e to the power of negative lambda x. So that just gives us e to the power of negative lambda x divided by negative lambda. And then we will evaluate this from 0 to infinity. And then we will subtract this by the integral from 0 to infinity of this entire term, but with this term as the derivative. So we will take the derivative of this x term, which is just equal to 1. So we have e to the power of negative lambda x divided by negative lambda. And then these conveniently cancel out. And for this term over here, when we evaluate this to infinity, we have this extremely small term. We have e to the power of negative infinity. So that dominates over this x term, so we just get 0. And then when x is equal to 0, we just have 0 multiplied by a constant, because it's just this entire term is just equal to 1 if you substitute in x equal to 0, so it's also equal to 0. So this entire thing is just equal to 0. We can just disregard it. So the only thing we have left is this lambda multiplied by this term, and then you can see that these terms also conveniently cancel out. So in the end, we're left with this relatively simple integral, which is easy to evaluate. We just find the antiderivative, and then evaluating this from 0 to infinity. So e to the power of negative infinity, that's just equal to 0. And then we subtract this by e to the power of 0, which is just equal to 1 divided by negative lambda. And so we get 1 over lambda, and this is the expected value that we're looking for.